Hello, everyone. Welcome to the Getting Started with Unity workshop. My name is Gary T, the co-founder and co-director of synHacks and Hack the World, and we're very excited to have Ben with us. And for those joining us on YouTube Live, if you have any questions throughout this entire workshop, make sure to drop it in the chat and we'll get that answered. But first off, I would like to introduce Rohan, our Outreach Director.
Thanks for the introduction, Gary. I'm Rohan Krishnan, one of the organizers for Hack the World, and I'm excited to introduce our workshop for this afternoon, hosted by Ben from Unity. This workshop is going to be an excellent introduction into using their service. So without further ado, here's Ben.
Thanks, Rohan, and thanks, Hack the World. Hopefully everyone's joined in and having a good day today. We're going to really focus today on how to use Unity, and this presentation is intended for someone that might be brand new to Unity. Maybe you've never even coded before. This is really an introductory course. So I want to start off with a little slide set that will talk about some points. Let me just bring this up and share my screen. All right, hopefully you can see my screen here. So I want to start off with what Unity is all about and kind of what you can use it for. And most of us know us as games, and that's kind of where we started with our bread and butter. So let's start there with a quick video about that. So I ended it just a little too soon there. So hopefully you're all able to see that okay, and kind of get an idea what we do. So my name is Ben Mcilmoyle, and I'm a developer advocate at Unity. And really what that means is I get to go out I mainly focus on schools, but we have a whole bunch of them. But I get to go to a lot of universities, high schools, really all over the world. And I either help out students or actually your teachers and how to use specific features of Unity. Sometimes it's a presentation like this, so it's just like general Unity knowledge. It can be a whole bunch of things. But today, like I said before, we're going to be talking about getting started with Unity. And like I said, this is a course or a lecture, I should say. We have about an hour and a half here to get our first introduction to Unity. So this is for someone that's never used it before. You might need maybe a refresher if you have used it. Don't worry if you're not a programmer or an artist or anything. You don't have to have any requirements from this. We're going right from the very start. And just to throw it here as well, at the bottom of the screen there, you can see my Twitter handle. If you do have any questions, maybe you want to reach out, maybe you want to show me the cool project you've been working on for this Hack Week, Twitter is definitely the best spot to do that. So go ahead and you can follow me there. If you want to DM me, those are open. If you want to, share your project, whatever it is, if you want to get a hold of me, Twitter is the spot to do that. So today, what are we going to be covering? I'm going to first start off with kind of what is Unity at a high level and what are the uses of it? What are we using it for today? Because like I said, games is what most people think about Unity as, but it's a lot bigger than that these days. And there's a lot of applications. So I know that most of you are participating in a Hack Week right now, and you might not be making a game. And you might go, well, why is Unity useful to me, and hopefully we can answer that for you in just a minute. We're also going to talk about the supported platforms, and I know a lot of you are probably using either a PC or a Mac device, but we support so much more than that. Pretty much anything that has a screen, we support it. So it's really useful to know that as well. We're going to do some live coding today. So we have a course that you can access at any time on Unity called Create with Code. And it's really a basic prototyping series that you can follow. I'll give you the links in a few minutes, but we're going to be doing kind of lesson one from that today. Then we're going to look at a little bit of where you can find extra resources, because we do only have a limited time today, and you're definitely not going to be an expert within an hour of using Unity. So if you find this intriguing, if you want to know more, I'll give you some resources that you can take and hopefully do a bit more of a deep dive yourself. We're also going to talk about the Unity Asset Store, especially when you guys are doing a hack week. It's really useful. Maybe you have an idea and you need a certain 3D model, or you don't exactly know how to write some code, but you know what you want it to do. You can often look at the Unity Asset Store and find what you're looking for. And sometimes it does have a cost associated with it, but there are lots of free items there as well. And then today we'll wrap up with a QA session. If you need help with any projects you're doing, if you have a general Unity question, whatever it is, let me know. I can take questions here both on the Zoom call. I know a lot of you are watching on YouTube, but if you're on the Hack Week's Discord channel, I'll jump on there as well, and I'll answer any questions that come my way. So let's start off today. What are the uses of Unity, and what are we seeing it used for a lot today? Well, yes, games is still the biggest part of it, and games is where Unity started from. So Unity as a whole was originally created to be a video game engine. So an engine is a piece of software that allows you to make your game without having to code everything from scratch. And if you've ever done that before, maybe you're like hardcore into like writing C++ and low-level shaders for your graphics cards. It's really good that you know how that technology works and how to use it, but it takes forever to do something. You'll probably be hours, if not days, just drawing a simple cube to the screen if you do everything from scratch. So using a game engine can really kind of boost your ideas and gets you prototyping things really, really quickly. And that's awesome for a hack week. You can get your ideas out of your head and onto a screen really, really fast. It's also become probably the world's biggest platform for XR, as we call it. So virtual reality and augmented reality, those two kind of combine together within mixed reality, or XR. So pretty much every headset you can use these days is supported through Unity. So like your Oculus Quest, your Oculus Rifts, the Vives, all of those. We also do augmented reality, so like the Microsoft HoloLens, or even if you're just doing augmented reality on your phone, you can do all of that directly within Unity. So I think that's where we start seeing it's getting a little bit interesting. So yeah, of course you could have a game in XR, but you can also do a lot of cool things, like maybe you're doing a medical simulation and you want to say, you know, we have a patient in front of us. What's the drug prescription that we should be giving him in the hospital? We can do a software like that within Unity. Has nothing to do with games, but it has everything to do with real-time 3D, and that's where we really shine. We also have some things like simulation, where you can actually run thousands of instances of Unity. So imagine you're making your project, and you can run one version on your local machine, or you can have as many as you need running in the cloud. And this comes out really handy if you're doing things like AI, machine learning, algorithms, anything that takes a deep dive where you need a lot of computing power. We also have that these days. What else are we using for? Well, we have some pretty interesting things happening in the film, animation, and cinematic space, or sometimes it's called media and entertainment. The screenshot you actually see up there on the screen is from the movie Lion King. I think that was last year, maybe the year before. But they actually used Unity in filming this by having virtual cameras. So we see a lot of mixing of technology. So the artists that are making models, like if they have little Simba here or whatever it is, they might not make the model directly in Unity, but they bring it in to give them control of other aspects. And what they did in particular with The Lion King was they used a combination of Unity and the VR technology, where they actually had virtual cameras. So they'd have a real cameraman walking around essentially a warehouse, a big open space, and he'd be able to see on his camera what the VR world is looking like, and he can move his camera so they can get realistic tracking shots. So they're kind of combining technologies of, yeah, it's a virtual world, These aren't real animals, and it's pretty hard to put motion capture suits on a lion. Definitely not recommended. So they do a lot of that with hand animation, but then they want to give it a realistic feel of there's someone with a camera. It makes it feel a lot more realistic, like the movies we're used to. So they actually combine that technology in Unity, and that enables directors to see in real time what these shots are looking like. You can actually see this is the full finished product, and this is kind of the lower resolution version that they would have seen on camera. But instead of a director saying, I want this shot, and then the cameraman trying to go out or having to draw storyboards, you can do that all real time in 3D. So you can see things really quick. We're also getting a lot of use in automotive transportation and manufacturing. So there's a lot of car manufacturers these days that love to have fancy, really nice looking models of their cars for sales purposes or for testing. And we have a lot of that happening right now. We even have companies that are going out and doing crash testing within Unity itself, using the physics simulation within Unity to get those reports. So you can imagine those car companies, they don't want to send a brand new $50,000 car down a track into a wall to see how it's going to crash and if it's safe or not. They might have to do a bit of that still, but they can save themselves a lot of money by doing this virtually inside Unity. And the last one I want to talk about is architect, engineering, and construction. This is becoming super popular these days. So I know many of you are quite young, but if you're out in industry, especially in the architecting industry, a big part of your job is visualizing and setting up these 3D models about what a building's going to look like, what materials is it made out of. Maybe you're in charge of putting up a new skyscraper, but you're working for a client that he's the actual owner of this building, or this company is the owner of the building. So you can do something like the guy's doing here, where you have an iPad and you have this spatially mapped out. Again, this is augmented reality, and you could be on the job site and be like, hey, you want to see what this is going to look like in 6 months when we have the steel beams and cement up, but it's not finished yet? Let me just type that up. He holds it up and he can show his clients or maybe his employees or whatever it is, what's going on. So it's really useful for being able to visualize these things before anything's built. And again, it's all about saving time and money. If you can get a product done virtually, get everyone to sign off and say, yeah, this is what we want before you have to build anything, you will save so much money and time because you don't have to correct issues later on. So onto the supported platforms. Here's a good slew of them, but there's a lot more than this even. Pretty much what I like to say is if it has a screen on it and it has the ability to render 2D or 3D images on that screen, we probably support it. So obviously we support the major platforms like PC and Mac, computer platforms, I should say. We support all the video game consoles, so Nintendo, Xbox, PlayStation. There's definitely games already for like the PlayStation 5 and the next gen Xbox as well, already all being developed in Unity. And I think this is really powerful when you think about it, because it used to be if you wanted to create a game or any kind of application, you kind of had to have in mind what you were building it for. So if you were making a PlayStation game back in the day, you would have to have the PlayStation dev kit, the PlayStation API, everything from a fairly early stage. These days, we often see that the development cycle has changed, where you can actually have someone, maybe they're just a small indie developer, maybe they're doing a hack week, there's 2 or 3 developers, they come up with a game or a project, and maybe it goes huge overnight. It just gets in the right streamer's hands, or it gets some investment support, and all of a sudden you have the need to bring it to other platforms. With using a platform like Unity, you can write it for your PC, and if it goes big, it's fairly easy to transfer to these other devices. Now, it's not just straight up, file, save as, export to the Nintendo Switch. Sometimes you do have to do a little bit of optimizations, but the core of it will move over, which is a really powerful thing, especially if you are doing something like a hack week. Design once and have it going to everything. So I don't want to talk too much more about what Unity is. I want to get into it. So let's talk about what you're going to need to do. So if you want to follow along today, you will need a copy of Unity. So the first thing you're going to want to do, and I will do this with you, but I'll explain it first, is go to unity3d.com or just unity.com and sign yourself up for a Unity ID. So you'll have to just set up an email, username, and password. You'll get an email, just to confirm that you're a real human, and then that's it. It's free to use. You don't have to pay anything or get any of the fancy licenses if you're just using it for something like a hack week. In fact, you can use Unity in your projects as long as you're making less than $100,000 in the last year. So pretty much, unless you're a big company already making lots of money, Unity is completely free to use, which is awesome. So I'll go through this actually on the website in a second, but please go ahead and start filling that out if you want to follow along real time. Then we're going to download a launcher program called Unity Hub. So Unity itself, there's a lot of versions of it. We constantly update it. We're constantly fixing bugs, adding new features, improving the engine. And what we found was developers needed a spot to manage if they had multiple versions of Unity installed. So Unity Hub is our answer to that. So you'll get used to seeing this window if you work with Unity. It'll list out all the different projects you might have on the go, as well as all the different versions of Unity that you might be able to build from. So we'll talk about that again in just a minute. And I bring this up and we will go through this, but when you actually go to create your first Unity project, you're going to see this window. When you're in Unity Hub, you say new project and you're going to get this. And there's confusion about what exactly I should choose for my project. So let's talk about it really quickly. For the most part, this has to do with setting up how Unity is going to look for you. And we kind of give you a few features that you get started with that'll make it easier depending on the game or the project you're trying to make. So I think the easiest example is, hey, are you making a 2D or 3D project? And we have both of those options, as you can see here on the screen. If you're trying to make a 2D game, or maybe you're making just like a cell phone app or a 2D project in general, then just go ahead and choose the 2D template. Then this is where it gets more confusing. If you're not doing that, what are these other 4 options? Well, it really comes down to, I think, 3 that you should pay attention to. If you're just making a generic app, which if you're following along in this course, you probably are, because this is an introduction, just go ahead and choose the 3D option. Now, the biggest difference here is that comes with what we call the built-in rendering pipeline. So that's the default rendering, which is drawing things to screen that Unity has used pretty much since day one. And it works. Most games you will have seen or played in Unity have used this at this point, and that's what we've been using for the last 10 or so years. But we have a few other things that are still in the works. They're available for you now, but we're still adding and improving on those things. So we call them the high definition render pipeline and the universal render pipeline. So what those two things are is our scriptable render pipeline. So a lot of big words here. What it really means is it gives you finer control of making really fancy high-end looking products. So if you're just getting started with Unity, you probably don't really have to pay attention to this too much. But let's say you are an automotive manufacturer and you want to have your new fancy Ferrari looking really, really nice. You might want to use the high definition pipeline because it gives you extra flexibility and options there to get things looking really pretty. So for everyone today, I just suggest we're going to be making a 3D game, and that's a where start. But if you're using this for your hack week, just decide, is this a 2D application or 3D, and choose one of those two. So we're about to get to code, I promise. We're almost there. We're going to be following a lesson from something we call Create with Code. So today's lesson comes from this online course you can actually follow, and I'll put the link up after as well, but there it is. This is a completely free course. Unity offers a whole bunch of different online lessons completely free. We just made them free a few weeks ago. And this one's really, like I said, intended for you've never used Unity before. But if you go to learn.unity.com, you can actually browse through all the different lessons there are. There's some on like XR, there's some on storytelling through Unity, a whole bunch of different features that even if you're not a complete beginner in Unity, you'll probably find something that's really useful. It has video walkthroughs, it has text. It makes it just about as simple as you can get. So I really encourage you, if you're trying to learn Unity, if you want to improve your skills in Unity, check out learn.unity.com, and you're going to find a lot of useful things there. Because like I said, we're not going to have time to get that far into the engine. It's such a big, complex machine that I want to make sure you have resources. So with all that said, let's actually start our coding. And I know I don't have that many people on the Zoom call. If you are following along and you get a little bit behind, that's totally okay. I don't want you to freak out. I will continue going through this lesson because we are short on time. And if you do miss something, you can either rewatch this recording, or again, you can go to that website, learn.unity.com. And in particular, this one is /course/create with code. If you just Google Unity Create with Code, you'll find it. So with that all said, let's go ahead and actually start this. I'm going to stop sharing for just a moment, and I'm going to open up Unity. Sorry, 1 second. So what I'm doing here, let me share my screen once again. Turn that off. Hopefully you can see my my browser at this point. If you're brand new to Unity and you've never used it before and you're not really sure what's going on, the best thing to do is just Google Unity, and it's going to bring you to unity.com. So go ahead and come in here. There's a lot of information here about how Unity is being used, a lot of the same stuff I just said. But what you're going to want to do is go up to this top right corner. You'll see this little like blank avatar icon. Click on that and you can do that, create a Unity ID. So just unity.com. Top right corner, you can create this Unity ID. So it's going to bring you to this page here. It'll be a little bit different. Obviously, I'm already signed in, but it'll bring you, if you haven't had an account, to an actual a sign up page. You can go from there. So I'll let you all do that on your own. If you are following along, it'll take a few minutes. You'll get an email just to confirm your account, and then you can go from there. So there's a lot of other information once that's done, and you can always do the getting started here. It'll talk you through a bunch of our different plans. What we're going to go for today, and what most of you will use for some time, is an individual plan, and it's going to be the personal plan here. And as you can see, it is free as long as, like I said, you've made less than 100,000 US dollars in the last 12 months. Completely free to use. And there are obviously these business licenses that have a few extra features, but I've never really come across too many features that you have to have a pro license. If you come to the point where you need a pro license, you're doing some pretty advanced stuff. So definitely this individual personal license will get you where you need to go.
I would also like to mention that if you're joining us on this hackathon, if you're a part of this hackathon, you also have access to the GitHub Student Pack, which provides the free Unity student plan.
Even better. We got you set up there too. So thanks for bringing that in. So next, we actually need to download Unity, the software itself. I find it easiest just to Google Unity download, and it should bring you to this page. If not, the actual address is unity3d.com /get unity/download. And like I said, there's a lot of versions of Unity here. And you'll be able to actually go in and select certain versions if you really need a specific one. For us today, we're just going to start off with download Unity Hub. So you can click that and it should pop up and start downloading it for you. Now, obviously, I already have this downloaded, so I'm not going to go ahead and walk you through everything, but let it download, let it install. I promise you there's no extra spam or any other weird stuff in there. You can pretty much just keep hitting next and it should install for you on your machine. Once that is done, you should either get an icon on your homepage, or you can just search on your own computer for Unity, and this should pop up for you, Unity Hub. And this is like what I said, where we manage all the different installs of Unity and we manage all of our different projects. This is also a great spot if you're brand new. On the left, you will see there's a Learn tab. And we have tons of tutorials and it'll walk you through things. This is linked to that same website I was just talking about. You can get some assets here. Maybe you're like, I want to make the next Mario Kart game. Well, we have a karting demo where you can actually get a more or less completed demo. It'll walk you through some like, I want to do this thing. How do I do it? It'll take you there. And you can also just mess around with it. That's what I really encourage anyone starting out with Unity to do, is mess around with it and break things. Go out and see what you can make on your own. Come up with an idea. Even if you don't know how to implement it to start, just Google it. There are so many information out there, or so much information out there. You'll probably find a fairly decent answer to start. But anyways, back to the main project page here. What we'll get you to do at this point, you'll need to sign into your account. So you've created your Unity account on the website. This will be a blank icon. It'll just be the little user icon again. If you click that, it'll bring up a sign in. So just sign in with that same username and password you just created online, and you should be able to have your free license or your student license, if that's the case. And then we're almost ready to get going. The last thing you'll need to do is, you've downloaded Unity Hub, but you don't have a version of Unity itself. So there's two different softwares here: Unity Hub, which is just the manager, and then Unity itself, the actual editor we're going to do. So what you can do is come down to installs, and you'll see I actually have two of them right now, but you will have nothing if you're brand new to Unity. What you can do is add, And what this is going to do is just give you a few options for some of the most recent versions of Unity. So there's literally hundreds, if not thousands of versions of Unity that have come out over the years. What I suggest you do is download Unity 2019.4 and you'll see LTS. LTS is an important thing for us. It means long-term support. So this is obviously last year's version. But it's the one that we've been like, yes, this is where we're leaving it for last year. We're still making lots of new things. There is a Unity 2020, but if you're using the 2019.4, it should be fairly stable. If any bugs do pop up, we're still supporting it, so you can still get things fixed. But at this point, it is very stable. So I suggest downloading Unity 2019.4. Just click on that, hit next, and it's not going to pop up here for me, I don't think, because I have it installed already. But one of the options you should get if you don't have it installed already is the option for Visual Studio Community. So Unity is the actual graphical 3D graphic, or sometimes 2D editor that we can use, but we still need to code in another piece of software, an IDE. And you don't have to use Visual Studio, but that is our recommended. We have it paired very nicely so all the IntelliSense works. So if you start typing something in, it's probably like, hey, do you mean this thing? And it'll help you code a lot faster as well. So make sure you select that Visual Studio version. And if you want to build for any particular other device, this is a good time to do it. You can do it after as well. But let's say, hey, I know I'm trying to build an Android app of some type or an Android game. Then I would just check Android build support, and it's going to install the correct packages for me. For today, you don't need any of that, just regular Unity, and the Visual Studio option should be there if you don't have it installed already. You can just hit done and it'll start installing for you. So depending on your computer speed and your internet speed, it might be fast or slow, but because we're pretty limited on time today, I'm just going to go into the demo and you can either follow along later, like I said, on the website, or you can rewatch this recording. So we got our hub set up. We have Unity installed at this point. Let's go ahead and create a new project. So if you have multiple versions of Unity installed, you can hit that down arrow and pick the one you want. Since I just said, let's use 2019. Let's go ahead and do that. And so it opened on my secondary window. But here we have this pop-up where you have these template options. For us today, like I said, we're just going to make a fairly standard, simple 3D game. So I will therefore select the 3D template. We're going to have a project name. Now, this is whatever it is you decide to name it. You can call it whatever you want. It won't change anything. I think we'll call this, what are we in? Hack the World, a demo. Totally up to you. And then we also have the option for location. Now, this is where we're actually going to build the project, where you want it to live on your machine. So totally up to you. I like to have everything in just a code folder, so I know where everything is, but everyone will be a little different. You have to set it up for your particular machine. So it's a good idea to remember where it is, but totally up to you. Then hit the create button, and you should see Unity pops up, and it's going to, so I have two monitors here. You can't see it right now, but I get a Unity, like a launching window. It just says Unity itself. Once it opens in just a minute, I'll bring it over to the screen so you can actually see it here. And once it's done, there you go. So this is the Unity editor itself. And I know there's going to be questions because there always are. People are going to say, how do you have the dark mode? Because by default, everyone's usually in the light mode. So it'll be a lighter gray and white colors around the edge. That is one feature of Unity Pro that is only available on the Pro licenses, that there is a dark mode. Everyone's always in love with the dark mode. I get it. But that is the one thing you can't get in the free version. So I'll put that out there now. But this is Unity itself. Let's talk about what we can see here on the screen. First of all, right in the middle, we have this, looks like some grids and a little camera icon and a light. What the heck is this? This is our scene view. So when we work in Unity in a 3D environment, we call it the scene. So the scene is like the 3D space that we can add all of our cool game or project components to. We also at the top here have a game view tab. So we have little tabs just like you probably have in your web browser. If you hit game, the view down here changed a little bit, but we're still viewing the same scene. But at this point, we're viewing it through the actual lens of the camera that we're going to use in our game. So imagine it kind of like a movie set is what we like to say, where you have a camera and you have one particular angle that you're trying to catch, and you know, maybe you have your actors and your explosions and whatever is happening in that one area, but there's a whole bunch of cameras and crew and lighting and microphones and everything else that you see off the scene, off the camera. And this is kind of like the scene view. When you're in the scene view, you can see everything that's going on. When you're in game view, it's just the camera and whatever's in front of it. So, okay, we have a pretty empty, boring looking game right now. Let's see if we can fix that up. Let's look what we have in our scene. Over here on the left, you see this hierarchy panel. So this lists everything that lives in our scene right now. And because we selected the 3D template to start, it set it up in a particular way that makes it a little bit easier for us to access. First of all, it gave us a main camera, and I can actually click on that. It'll show me where it is in the scene view. And if I want to fly up to it, I can use my arrow keys, and you can see I can move around my scene with the arrow keys. I can also use my mouse. I like to use an actual mouse. Some of you, I'm sure, are on trackpads. Should work either way. If I hold my right click, I can look around, kind of like a first-person game, and I can combine that with the movement, so we can move around our space. Now, I have a particular way I like to get around the scene. The one nice thing with Unity is there's any way you want to do things, you probably can. So the way I get around and set up my version might be different than if you've done it in the past. And there's not a right or wrong answer. So if you see something that I'm doing, you're like, oh, that's not what I do. That's not right. There really isn't a right or wrong. It's whatever you're comfortable with. And the longer you use Unity, you'll find lots of tips and tricks and what works best for your workflow. But for me, I like the arrow keys and the right click to look around. So there's my camera. You can see it sitting there. We have a little camera icon and this white box that comes out of it. That's our viewport. So that's what the camera is actually seeing. It's kind of like a rectangular cone, if you will, or like a pyramid shape. We also have a directional light. So in 3D games, we often use lighting. And this is just a kind of a generic one. A directional light, you can think of it, it's pretty much like the sun. It's this big infinite thing. You don't actually ever see like a light bulb or anything. It's just this big light that's coming from one direction down onto the scene. Besides that, it is completely empty though. And this is where I want to get into the create with code content. So it's a whole series about learning how to use Unity. What we're going to do today, and actually this might be interesting because a lot of you aren't on the Discord. I was going to give you a link there, but let's see if I can do this in another way. I will throw this link on into the chat just in case some of you are here. If I can. So that is in the chat for anyone that is here right now. What that'll actually do is download a package straight from the Create with Code website, and it'll kind of serve as our starting point. Now, because I know a lot of you are watching the live stream instead, I'm going to go a little bit off script and try to do this live. Sorry, let me just bring it over here. So all I did was Google Create with Code, and you'll see right away Create with Code Unity Learn popped up. If you click that, this is the actual course itself that you can go through to get started. We're going to focus mainly on Unit 1 here today. You probably have to sign in. You can use that same Unity ID that you created to download Unity. And then, like I said, completely free. You'll have full access to this. So if you're using that link I put in the Zoom call, you can just do that. If not, come to Unit 1, Player Control, and you'll have to go into Lesson 1.1 and then tutorial materials. So we're going to be using this here today. You can either get it from the asset store, which we'll talk about near the end of this presentation, or what I just gave out was this actual direct download.zip file. So I'll do that right now. It's going to download a zip file for me. I can go ahead and all I'm going to do is extract it. So on a Windows machine, you can just right click and hit extract all. Now I've done this already in the past. So let me see if I have one that's open. And you'll find this inside prototype-1 starter files. Now, if Unity is open, which mine is in the background, all I'm going to do is double click this. And let me bring this in so you can see it. You're going to get this import Unity package window. And you don't have to do this. This isn't definitely not a requirement for every Unity game you make. Quite often you'll start with nothing and you'll build everything yourself, but we don't really have time to create 3D models and everything. So what this is going to do is actually bring in a bunch of 3D models that we can use in this example. So I'm just going to hit import. Just give it a second to load up, and it's going to bring all these new models in for us. So if you're being very vigilant there, you might have seen a flicker down here in the bottom. This panel we have here is what we call the project view. And this is where we can store all of our assets. And assets are a big topic, but you can think of like our 3D models, maybe some music, fonts, scripts we write, pretty much anything you use inside the game to make the game is an asset. And this is where you can actually check it out. So we have down here, we have scenes. So we're in a big empty scene that you get by default. But because we just imported that package, you'll also have this prototype 1. So I just went ahead and double clicked it. And now we kind of have a starting point we can use for today. And again, if you're missing this, I know I'm going fairly fast because of the time constraints. Just check it out online. It'll walk you through this with video tutorials of everything. So if you're missing out on this, please don't freak out. I know I am going a little quick. But definitely you can catch up there if you need to. So what did this just give us? Well, it brought us to this new scene. You can see we have a kind of a skybox. We can look around, some mountains, and we have this road in front of us. And if I look now in my hierarchy panel, I'll see, hey, some stuff changed. I still have my main camera, still have my directional light, but now I have this environment. So this is what someone at Unity has gone through and created for us. And I can use these little arrows to open and close things, just like your file explorer on your local machine. And you can go in and you can just like click around and you can see all these objects we're clicking, all these names we're clicking correspond to something we can see in the scene. I could also, maybe I'm like, hey, I want to change something about this particular piece of road. I can also click on it if I'm in my scene view. If I'm in my game view, you can't click on it here. But if I'm in scene view, I can. So this is a good time if you actually look and see in our game view, this is what our game looks like through the camera's eye or through the camera lens. And this is what we can see you can look around and see all the behind the scenes stuff. So cool. We have a basic scene. Let's actually add something to it and get something going. So again, part of that imported package we just had, if you come down here in the project panel, you'll see there's this course library section. And we actually have, you can go ahead and see if I can find them. These FBX, here's all the actual like 3D models of the vehicles and things we can use. But again, because of time constraints, we're not going to go through and like go and take this blank 3D model and actually color it ourselves. Instead, let me just delete what I just added. Instead, if you go to under course library and then vehicles, you'll see we have a handful of vehicles that are already set up that we can use quickly today. So completely up to you, whatever you want to use. I think I will use maybe the tank because, why not? That's pretty fun. So all I did to get that into my scene, so nice and easy, I just literally grabbed that, dragged, and I can drop it, wherever it is I want it to be in the scene. I'm just going to put it there. Looks pretty good to me. So now that I have this tank in my scene, let's check out this inspector a little bit and see what's going on here. So we know we can access all these things in the scene over here. And these things, as I just mentioned, are what we call game objects. So anything that lives in the scene that you see in this hierarchy is considered to be a game object. So our camera is a game object. This tank is a game object. This entire environment is a game object. It's a pretty core concept to understand. And if you don't quite get it yet, don't sweat it. Once you start using Unity, you'll pick it up pretty quick. So if I look at my tank, I can click on that. And you'll notice this window over on the right starts changing. Now, this is what we call the inspector tab. And the inspector has a bunch of information that pertains directly to whatever game object that we selected from over here. So again, I select my tank, and then everything that's related to the tank pops up on the right. Now, we're not going to have time to go through everything today, but you can see we have a transform. We have these mesh filters, which is the actual 3D model itself. We have the mesh renderer, which I can turn on and off, and you can see that's responsible for actually drawing the tank to the screen. We have a mesh collider, which we'll talk about in a second. But I really want to touch on this transform. What the heck is a transform? So transform is what actually stores all the information about where the 3D object is within our scene. So imagine again, it's like a movie set. You have this big empty warehouse. You can put in whatever it is you want into it, and then we're able to control exactly where it lives in our scene. And there's multiple ways to do it. First of all, if I have my my tank selected, you might notice some arrows popping out of it. And I can actually use these arrows to move the tank. I can just grab it and drag it to move it around the scene however I want. And as I do that, pay attention to this transform. You'll notice we have an X, Y, and Z coordinate that we can move around. And as I move that, it changes it. So I'm sure a lot of you, I know a lot of you are high school or college level, and you've probably dealt with like Cartesian planes and maybe a bit of like calculus where you're dealing with 3D space in the past. And you probably say, hey, math teacher, we're never going to use this. It's useless. It's very important in gaming. If you want to get into gaming or any kind of 3D modeling or 3D computing, it's something you're going to need. So pay attention in those classes. So for us here, we could also change this value by just clicking on it. If I want to make sure it's in the middle of the road, I know the road's lined up. If I set it to 0, we have it lined up perfectly. If I drag it to the right of my screen, positive on the x-axis, you'll see that number goes up. And if I drag it to the left or negative on the x-axis, you'll see that number goes down. So we won't spend a whole lot of time on a math lesson today, but this world works just like your math lessons probably have in school, where you have a positive and negative on any given axis. X is left to right, so horizontal across the screen. Y is up and down, vertical on the screen. And then Z is our depth, so like in and out of the screen. You can see it going there. So we can play with these objects and set them up however we want that way. We also have the ability to rotate them on any of those axes. So I can rotate it around the x-axis, the y-axis, and of course the Z or Z-axis. I'm Canadian. Sometimes I say Z, sometimes I say Z. That's just a little side note for you, though. And then we also have scale. We can actually stretch or skew our objects on any of those given axes as well. So maybe you're making, I don't know, some kind of tank game where you're just trying to cover the road and run over a bunch of cars or something, and you want it to be wider. You could do it there as well. Now, of course, it does get a little squished looking and a little bit weird looking. If you wanted to correct this issue better, you'd probably have to change the model itself. But for getting a prototype up and going, we're able to do that right there, which is pretty awesome. So what else can we do here? Let's actually make it so we can drive this tank around a little bit. We're going to write our first bit of code. So I'm going to go to my assets down here in the project directory, and I'm going to actually create a new folder for these to live in. So you can see, just like your file explorer on your machine, all your files of everything that lives in the game, you can go and you can view them here. And you can also create and organize them here. So I'm going to go under assets. I'm going to right click in this area, go up to create folder, and I'm going to name this scripts. Now, technically, you don't have to do this. This isn't something that's going to make it, the Unity runs or doesn't run. This is purely for keeping your code base clean and keeping your project clean. I don't know how many times in my career I've tried to make something. I get busy. I come back 6 months later and I say, oh, what a mess. What was I doing? I can't find anything. Where is everything? Making sure you have good organization from the beginning will save you in the long run. Trust me on that. So I'm going to go inside scripts, and then I'm going to right click, go up to create, and then a C# script. So Unity, we use C# as our programming language in there. If you don't know it, don't worry. You don't have to be a master programmer or even really a beginner program to get started. That's kind of the beauty of it. But go ahead and click that. And it's going to pop up. It looks like a little hashtag. It's like a sharp symbol, like a music sharp symbol for a C# script. And I'm going to call this player controller. And based on that name, you might guess it's going to control the player, or for us, the tank. And I want this script to somehow live on this tank object so that it can drive it around. And there's, again, lots of ways to do it. I think the easiest to do it when you're starting is select the object you want the script to live on, and you can literally just drag and drop it onto that object. You'll see it went blue there. If you wanted a different approach, some people don't like that. I can undo it. I can actually go and I can either drag it on up here, and you'll see it would have just popped up. I can also drag it onto the scene. It pops up. It gives you the same result. Whatever way you find comfortable, it's really just drag and drop it onto that game object. After that, what I'm going to do is double click the player controller. And this is why it's important to have Visual Studio installed. It's going to open Visual Studio. Sorry, it opened on my second monitor. And it's going to give us a little template we can start with here. So we can write all of our code in here, and whatever we put in here, the tank is going to listen to and respond with. You'll see two functions. And again, if you're not a programmer, don't sweat it. You'll see this void start and this void update. What are these two things? So anything we put in between these two little squiggly brackets here will happen at the very beginning of the game, right as the game is starting, hence the start function. Any kind of code we put in here will be executed at that point. We're not going to do that quite yet. Instead, we're going to look at this update function. And as it says, update is called once per frame. What is a frame? Well, you can think about computer animation or computer rendering a lot like traditional hand-drawn animation. I'm sure at some point, most of us as kids have gone and got like a notepad or a matchbook or whatever it is, and we draw a bunch of images, we flip through them really fast, and it looks like an animation plays out. Video games and 3D animation rendering are no different. We actually draw a whole bunch of independent frames, usually at 60 of those frames per second, to create nice, smooth animation. So this update function is directly tied to that. Anything we put in this update function will happen between every time we draw one of these frames. So we can do something like get it to move forward by, well, let's go back to Unity for a second. I think if you're a beginner, this is a good approach to do it. What I want to happen is I want the tank to start driving down the road. And you might be like, well, I can do this manually. I can drag it and do that. And it's not a bad approach, actually. It seems kind of trivial to do this, but as I'm dragging it, you can actually see my transform position dot Z or Z is moving. So somehow I need to do this in code. I need to have access to this transform, and I need to somehow be able to modify this Z value to get the tank to move. So let's go back to our code. We can actually do that by just typing in transform. We can say, hey, this script we're writing lives on the tank game object, and that game object has a transform on it. So all we have to do is ask for its transform. Oops, sorry. And then we have a bunch of options we can get from it. We could ask for its position. We could get that kind of information. We could ask for the scale, the rotation. Oops, rotation, there we go. Pretty much anything you see here as a value comes from code somewhere. So if you're brand new and you don't really know what's happening, this is why Visual Studio is so great. You can be like, well, I want the transform and I want it to move. So maybe I could change its position, and it'll kind of give you a reference to what you might want. Now, it might not always be obvious, and we're actually not going to move the position directly, although we could. Instead, we're going to use this other function called translate. So again, maybe back to some like public school math for you. If you remember, we talked about translating or moving objects. It's when you move an object on a plane without rotating at all. You just kind of, it's like you're sliding the object around more or less. So we can ask, hey, transform.translate, can you translate or slide this object around for us? And of course we can. And if I start typing in my brackets here, I start getting a suggestion of what I can put in here, and it says a vector 3. What the heck is a vector? Well, let's get it to working first, and then we'll talk about what we do. So I'm going to type in new vector 3, and if you have no idea what's happening here, don't sweat it too much. I'm going to give it 3 values. Remember, I want it to move forward on the Z-axis. I can do this in Unity itself. I want it to move forward just on the Z-axis. My X and my Y aren't changing at all. A vector 3 represents those 3 numbers. Really, it's just 3 numbers that are put together that we can use to represent some interesting things. So what we're going to do to start is just, how do we want it to move? Well, we want it to move positive on the Z-axis and none on these other 2. So if you imagine it's just those same 3 numbers, I want it to be 0 on my x-axis, 0 on my y-axis, and I want it to move positive into the distance on the z-axis. And you can play with it to get a movement that you think looks good, but let's just start with the value of 1. I want it to move 1 unit forward every time this update function is called, which is every time we redraw the frame. So let's just start with this, 1 line of code, and let's see what happens. So once you come back to Unity, you may have seen it just loaded up really quickly there. It's just building all the scripts in the background, getting them ready to go. And if I hit play at the very top, all right, if you were paying attention, and this might get lost on Zoom because Zoom is a little choppy sometimes. The tank was here and it just took off. It's gone now. And actually, I can leave it running and go back to my scene view, and I can double click my tank. You can see it's going real fast, but it's actually driving itself forward right now. So just with 1 line of code, we're able to have it just kind of drive off into the distance. Now it's moving really fast, and we can talk about what's going on here. You can think that our rendering loop, or how we're animating this, we're trying to aim for 60 frames per second right now. If this update call is called 60 times per second, and we say, hey, let's move forward 1 unit every time we do this, we're moving forward in 60 units every single second. So it's quite fast for this scene. Instead of doing that, let's actually make the speed a little bit slower. So if you're like, hey, that's about, I don't know, maybe it's 4 times faster than I want it to be. Logic would say make this this number 4 times smaller. So essentially divide 1 by 4, I get 0.25. Now, if I just type that in, it gives me that little red squiggly, which means there's an error there. And if I look at it, it's like it cannot convert a double to a float. What the heck does that mean? Don't worry about those values right now. A float point in computer science is really like a decimal point number. And Unity works on those, and just don't really worry about why this happens, but to make sure that it is a floating point so the computer understands it's a float or a decimal number, you have to put an F after it for float. So 0.25 F. And if I do that and give it a second to load, I hit play, we should see it drive off. It's still going quite fast. Oh, I'm away from it, but it's a lot slower than it was last time. So cool, we have the tank moving. Let's see what else we can do with it to make it a little bit more exciting. First off, having it move forward like this is great, but it's a lot of code to write. So we created this vector3, which is really just that X, Y, Z pairing. But I'm going to change this now and make it a little bit easier. I'm actually going to type in vector3.forward. We know we want our tank to move forward, so I'm just going to say, hey, move forward. And what this is really doing, it's almost like we just had in our code, but it's giving us the value 0, 0, 1. So we're back to making it move 1 unit per second, so 60 units per second right now. Sorry, it was 1 unit forward per frame, which means 60 units per second, which is okay, but it's pretty fast. So let's try to change that. What I can do to get that number down is multiply it by some scalar that will either make it faster or slower. So I said, let's make it 0.25 F for float before. Let's do that again. And if you're not great at math, don't worry about it too much. Most of us, I think, understand the concept that if we take 1, like the number 1, and we multiply it by any value, it becomes that any value. So 1 times 1 is 1, 1 times 10 is 10, 1 times 100,000. Vectors work very similar to that, where this vector is what we call normalized, or it has the length of 1. Now, if you haven't been over vectors and all that in school math yet, don't sweat it. You don't fully need to understand this. But if I take this value and I multiply it by another value, essentially it becomes 0 on the X, 0 on the Y, and 0.25 on the Z. I know it's a lot of math. We're going pretty quick here, so it can definitely be confusing, but we're slowing it down to about a quarter of the speed it once was. So let's see how this looks. It's okay. It's going on and it's doing some stuff, but we're also losing it and we can't really track it very well right now. So let's try to solve that issue next. What if I want to move the camera around with it? Let's go back to our scene view. And our camera, I left it way off somewhere. If you ever want to get back to a particular area or a game object quickly, I like to just double click on the game object and it kind of snaps to it nice and quick for you. So we have our vehicle and our camera was, there it is, rendering off to the side, like we see there. I want it to follow my tank around. I want it to be right behind it. To do that, we can use a very useful part of Unity or really 3D projects in general, which is parenting and anchoring a game object to another. So what do I mean by that? Well, let's set it up kind of having it look like we want to be in our game. I want it to be kind of behind the object and up behind it. So let's just kind of set it up manually to start. Kind of want it to be like back here-ish. It's not perfect, but we can fix this after. And I don't want it to be looking off into the mountains. I want it to be looking directly over the tank. So what I can do is change its rotation, and you can see it's set to -90. And you can either just grab it and manually adjust it to how you like. But I know mathematically it should work out to be 0. And you can see the little preview here. But even if I go to my game now, the camera's facing a different direction. So if I hit play right now, at least it's facing the right way, but it's not following our tank just yet. What I'm going to do for this is go to our main camera here on the hierarchy view, drag and drop it onto my armored car. And it doesn't look any different in our game view here, but if I hit play, you'll see it's now following our tank around, and it's not the best view ever to see what's happening, but let's see if I can do it maybe this way. Just pause it, and you can see that relation, the position relation it had from our camera to our tank stays the same, even if the tank moves. So when I took that camera and I dragged and dropped it onto the armored vehicle, it sets it up to be a child of it. And what you can actually see is wherever I drag and move that tank, the camera keeps the same spacing or distance between it, but moves around relative to where the tank is. So it's a very handy trick that you can get objects to follow other objects. You may or may not know how it actually works in like AAA games, but quite often, let's say you're playing Call of Duty or Fortnite or something, you don't want your 3D character modelers to have to go out and model. Maybe they have 100 characters in the game and there's 10 different weapons they can have in the game. If you had to take your 100 characters and then model them, including, the pistol, the rocket launcher, the machine gun, whatever it is they have, and you had to update that every single time, that's a lot of work for those animators. So what we typically do instead is set up our basic character, and we can actually use something like this to be like, hey, he has the same animations he plays, he's running down the street, but if he has the machine gun versus the pistol, we can just set it up to be a child of that character's hand, and wherever the character's hand moves, that object goes with it. So it's definitely really useful, and it gets used all the time in video games. So at this point, we're able to follow our tank around, and we're able to see it go into the distance, but I want it to be a little bit more controllable so we can actually do something with it. We can drive it ourselves. So let's go back to our tank and open up our code once again. Oh yeah, so that wasn't our tank. That's our tank. I can double click my player controller. So this works to drive it forward, but I want to get some user input. I want to pick up on some control and let us drive it front and back. So let's try to do that. Let's make a value here. I'm going to make a float, so a variable type. And I don't have time to go over variables if you've never programmed before. If you're a little bit confused, I definitely, again, suggest, I keep saying this, I know, but that create with code, it's a lot slower paced than this. It's the same content, but it happens a lot slower, and they go over every single topic through video and written out text as well. So if you really want to get started, it's a great spot to go. But for me, I'm going to create a float variable, and I'm going to call it vertical input. So I want some value, again, a decimal point value that represents the what the player is doing. And I can do this using our input system, which we can look up in code with input.getAxis. And I'm going to give it the value of vertical. And I want to make sure we have some time for some questions at the end. So I'm going to go through this fairly quick. But what this is going to do is it's listening for input, and you can set these up to be however you want. But by default, out of the box on Unity, it's listening for the W and S keys. So up and down, like a lot of you have played in like a first-person shooter, or the arrow keys up and down. And it's going to give us a value between -1 and +1. somewhere on a scale between there. So it could be negative 0.98, 0.1, 0.99, all the way up to 1. So somewhere it's going to give us a value in that range. Now, instead of just having multiplying it by just a hard value like 0.25, I can replace that with my vertical input. So if I'm pressing forward or my up arrow key, it's going to give me the value of 1. So I'm just going to be, again, I'm going to be traveling too fast, but I'm going forward at 1 unit per frame. If I'm traveling backwards, it'll give me the value of -1. If I take this value and I multiply it by anything, it kind of becomes that anything value. So all of a sudden, this vector is going backwards. We've just inverted it. So now it's -1 on the z-axis. So let's see if this works. I can going super fast, but I can control it. I can press up and down, and I'm going in and out of the scene. Now it's going really fast. So let's try to slow that down and fix an issue as well. So yes, I can control my tank. I can get some input and I can make it go forward and back. It's going a little bit too fast though. Let's see if we can slow it down. We can go back and then actually multiply this value by whatever it is to make it faster or slower. So for us, it's going to be slower. So before we had already multiplied it by 0.25 to slow it down. I'll put that back in. So what's happening here is we take our vector going forward. We either say, hey, you're moving forward by multiplying it by -1, which just keeps it positive, or we can multiply it by -1, which then makes it go backwards. And then if we take that same value after we've multiplied those two and add on 0.25, it'll slow it down to 1/4 of the speed. So let's try this. So I can control it. It's, it's going a little quick maybe, but it's reasonable. Now, one of the powerful things about Unity, and especially if you're working with a team, let's say you're doing your hackathon and you have maybe a programmer, maybe an artist, maybe a designer or whatever. You don't want to have a designer or an artist have to come in and ever touch any code. It can make things messy. It makes things confusing for them. Maybe they want to be able to run it in Unity, but they don't want to touch code, but they want the ability to change things still. We can do that by declaring a public variable. And again, if you're not sure what variables are, definitely watch the Create with Code full. The full course. It'll explain it a lot better. But for us, we're going to create this public variable. It's going to be a float. And I'm going to call it speed. And what I'm going to do, instead of multiplying it by this hard-coded value, so by the by 0.25, I'll put in this speed variable. And you might say, well, what's it set to? We don't say 0.25. We don't say what this value actually is. And this is where Unity is really kind of powerful and cool, because if I go back into the editor, give it a second to load, and I look at this script we added before, I now have this speed variable that I can change directly in the editor. So let's say you're the programmer, you've set stuff up that you can, I want my vehicle to drive back and forth, but my designer is the one who should really decide how fast it should be going. Your designer can open Unity and they can just sit here without, changing any actual lines of code and say, hey, I think 0.25 was a little fast. Let's try 0.15 instead. I can save it, run it, and now I'm going slower, and they never have to actually write code. They can just change values right here, and it's really useful. Now, the one last thing I want to talk about with driving forward and backwards before we move on to a little bit of turning is, let's see here, is the way we have this set up right now in this update function. I'm sure lots of you have a whole range of computers. Some of you probably have big, beefy gaming rigs at home where you're rendering out your, Fortnite or whatever it is you play at like 240 frames a second. You have a crazy fast monitor, crazy fast computer, and you're able to do that. Some of us might be playing on a mobile device. Maybe the best they can get is 30 frames per second. Right now, this function is directly tied to that. So if I'm playing on a super fast computer, this function will have been called 240 times per second, maybe faster, maybe slower, but let's use that as our baseline. If I'm on my mobile phone and it's only calling it 30 times a second, well, we're going to have a big difference in how our game feels. The person that's playing on the PC is going to feel like it's way harder to control. It's way, way faster. And then opposite for the person on the mobile. So we want this update function. It's very useful, but we don't want to necessarily tie the movement directly to every time the update gets called, because that is a variable amount depending on your technology. What we can do is multiply it by time.delta time. And this is a fairly big topic in its own, but time.delta time actually gives us that sliver of time, a fraction of a second between the updates. Like, how long has it been between the last update and this update? And by multiplying it by that value, we're going from tying it to the frame rate to tying it back to a per second basis. So if we are moving this tank 1 unit per frame and we had 100 frames per second, it would have moved 100 units, or 100, you can say feet, meters, whatever it is where you are, 100 units forward. But if I multiply it by my time.delta time, now it would be 100 units per second instead of tying it directly to a frame rate. So definitely a bit of an advanced topic, but very important that we use this delta time. And we're going to see things have slowed down a lot in our game if you just play it right now. I'm holding forward and it's changing the value, but practically you can't see anything. Nothing is really happening. You're going to have to adjust your numbers a little bit here. Instead of thinking of just how many units per frame now, I can think about it how many units per second. And I'm like, hey, maybe I want it to move 10 units forward. You can see our grid kind of in the background there. So I can go back to my tank and I can change the speed to be, so let's say 10 units per second now. And it's a lot more manageable. So I can move kind of slow, but I can definitely move in and out. The last thing I want to get to today, I want to leave some good time for QA at the end. Let's have it so you can rotate the tank a little bit. Now, it's going to be a little bit funky. It's not going to look quite right compared to what you'd expect a tank or a car to handle. You'd have to do like a complete physics simulation to do that. With us, we're just doing it through code, so it's going to kind of move on one axis directly. But let's set this up fairly quickly. I'm going to come back to my code. I'm going to actually create down here another float. If we had our vertical input before, so going forward and backwards, we can actually use a horizontal input to get left and right. So let's do a float horizontal input. I'll set that input get access to horizontal. And that, again, it's going to give me a value between -1 and +1, but now on the left to right axis. And I can do something similar here. I can ask my transform, if I can spell it right, dot, and last time I used translate. This time we want it to turn or rotate. So I can use my rotate function. And I can give it a value based on that. Now you're going to want to rotate around a certain axis. So if I do it here live in the editor, I want it to rotate around this green arrow, this green axis. Imagine you have this tank in front of you and you take a giant skewer and you just kind of stab it through the top. You can imagine how it would spin around that skewer or that axle. Same thing happens in Unity. Imagine that green line. We know it represents our y-axis if we're moving it around. It's also going to be the y-axis we rotate around. So let's do, you can see here, here's my rotation. Oh, and that's actually just the turret I grabbed, but same idea. If I go around that y-axis, it's completely turning the tank. So we're going to do the same thing here in our code. We're going to rotate around that axis. So let's go ahead and use this here. We're going to use our vector3.up. That's going to tell it which axis to rotate around. So that's our vertical y-axis. And then we want to tell it how much rotation we should do. Now, this, I think, is where we need to, we can figure out how fast we want it to be. Let's say we want it to turn 20 degrees per second. Maybe that's too fast, too slow, but it's up to you. You can multiply that by our horizontal input we used up before. And then again, we need to include the time.delta time to make sure it's not locked to our frame rate. But even with just that created there, we should be able to, if we've designed this correctly, let's see, we should be able to rotate now. So yeah, it's a little funky. It makes a little bit of sense with a tank, but I can definitely drive and I can turn my car and go around the scene. So I want to cover one last topic before we go to Q&A. It's a lot less on the coding. In fact, I don't think there's any coding to it. Let's add a little bit of physics to our scene here. So if I look at my tank right now, it's not controlled with physics at all. We're just purely taking it and moving it around the scene as we see fit. But we can add physics in Unity really quickly. What we can do, click on your tank. I have it called vehicle underscore armor car, whatever. Click on that. Come down over here on the inspector view, and you can do add component at the bottom. So like that script we've had as a component, this transform as a component, there's a whole bunch of different interesting ones you can add depending on what you're trying to make. For us, I said we want some physics. So let's find the physics options. And you see a bunch of colliders in here, which are great. But then what I want to add is a rigid body. And without going into too much detail, rigid bodies are what actually can control physics calculations. So like gravity, what happens if the tank hits an object? How does it bounce and move around? And I can just, I've added it. There it is. I can hit my game and it doesn't really look all that different. But if I go and like drag my tank up, you'll see we have some gravity being applied now. It's being dragged down into the scene. And I think just before we turn this over to the QA session, let's make this a little bit more interesting. Let's give us something to run over with our tank. So coming down to the projects panel, if you go to obstacles and we have a bunch here for you can use. I think the crate is a good obstacle. Let's just add one of those to our scene to start. And if I just run my scene right now and I go and I run into it, I get some really weird stuff happening. And it looks like our crate is like immovable. You can't move it around. And that's actually what's happening. By default, it has what we call a collider on it. And colliders are responsible for defining the shape in the physics engine. So it'll tell the physics system that this is a box. And what you see versus what the physics world sees in any video game are actually two different things. And usually the physics world is a lot more simplified. So instead of having, I mean, the box is a good example because we have like a box collider, but like maybe you have, maybe you've been playing like, I don't know, Counter-Strike or some other first-person shooter. And you're like, hey, I swear I just got a headshot on that guy, but it didn't say it counted. It looked to me like it was there, but it doesn't. Oftentimes we'll actually see we have colliders or hitboxes in our games that don't match up perfectly with the object. And that's on purpose for performance mainly. So I think this tank actually has some good examples where underneath we can just see some general boxes just to kind of like nothing gets stuck under it and like we can define it in the physics world, but it doesn't actually line up with what we see perfectly. And I'm sure you've all experienced that in either a shooter, maybe even playing like Mario or a platformer where you walk up to the edge and it looks like he should fall down, but he stays floating there. That's because the rendered world and the physics world don't perfectly align. And that's true for pretty much every video game. So on this box or this crate by default, we have a collider, but we don't have the rigid body. And I said rigid bodies are responsible for actually doing the physics calculation and making it bounce around. So we can collide with it right now, but we don't actually see it like fly off into the distance. So last few steps here, let's go ahead and go to our physics and add again a rigid body. Actually, you're gonna have to pause this first, or else it's gonna reset on you. Go back to your crate, add a component, physics, rigid body. And it's not going to look any different, but we should be able to run into it and see it move now. And there should be one more bug we fix up, and then we'll go on to Q&A. So I can move it. It's a little bouncy, but it definitely moved for me. And again, without getting too much into this, obviously there's a lot of physics calculations happening behind the scene. We didn't have to write anything. If you wrote this yourself, it would take days, probably weeks worth of code to get even a simple collision like that to happen. But we can change these values a little bit using real world physics, more or less. So if I look at my rigid body on my tank, I'll see it has the mass value of 1. Now, normally we like to tie this to kilograms, but it's really like how massive or how much weight is behind an object. 1 is virtually nothing. It's a very light object. I have no idea how much a tank weighs, but I know it's a lot more than 1. So let's just say 5,000. Again, I don't know the exact value, but I know it's bigger, so I improve that. Our little box here only has the mass behind it of 1. So you can imagine, it's just like real life. If a big object hits a small object or a massive object hits a smaller object, we should see this object move a lot farther, and we shouldn't see all the bounciness from the tank the same way. So let's see. Looks like our tank barely moves, but you see it can push around our box a lot easier right now. So I think that's a good point to leave our demo today. It's obviously just a very starting point to it. Unity is so much more powerful than this demo shows. I'm sure you've all played games in Unity before that look a lot better and control a lot better than this, but you have to start somewhere. And I think one of the big takeaways of today, I'm just going to switch my slides here, is that it can often be intimidating to start a new project or a new software like Unity. It seems like there's so much to learn. There's so much to it. I don't know how to code. I don't know how to do this or that. But I'd really encourage you to get in here. It's all free. There's plenty of resources online, and there's lots of either both official like forums and websites you can go to, but you can also ask a lot of people in your communities, and there's a good chance someone will know something and be able to help you. So before we switch over to QA, there's just a few more slides I want to end off with. Let me share my screen once again. Oops. One day I'll get this screen sharing stuff down. Let's share this. So let's say you are interested in Unity. Either you followed along today. I know it was really fast. It's probably a little bit hard too. But let's say you want to go further with Unity. What can you do to do this? I think there's three sources that you should really look into. One is Unity Learn. I've been preaching it from the beginning, but learn.unity.com. It'll take you through tutorials just like we just did. It'll be a lot slower paced, I promise. They'll take a lot more time to explain smaller concepts. It's like a learning management system. I'm sure a lot of you are doing online learning of some type where you have steps. It'll be like, watch this video. It'll explain, here's 2 lines of code we're going to do. It explains what they're all about, and then enables you to go through and do it as well. And we're actually doing live sessions right now. I think they're on week 3 or week 2 right now, actually. So you might be a little bit behind. But you can actually come to live sessions where people like me or other Unity employees will sit there, we'll take you through some stuff. We answer questions live. There's thousands of people doing this all at one time right now. So it's a great time to jump on there. Again, completely free. The Unity forums, you can go to forum.unity.com, and there's all kinds of questions about every topic you could imagine there. So if you can't find something easy just by Googling it, if you have a specific question, you can ask it there, and either an official Unity or another member of the community will come and help you out and hopefully get it done. We also have some pretty vast resources with the Unity documentation, just docs.unity3d.com. Pretty much all your basic subjects are covered there if you need more information. And even some pretty complex ones as well. If you're fairly comfortable with Unity, but maybe you're using it for a project like a hack week, and you're like, hey, I need a model of a realistic looking tank or something like that, we have a solution for you. We call it the Unity Asset Store. You can just go to assetstore.unity.com, and it might be 3D assets like 3D models, 2D sprites. It could be music and audio you can use for your background. Computer, there's AI, pretty much anything you can create in Unity. We actually have it that you can go and potentially buy it or even find it free. And it's also open that you could go and create your own assets, whatever it is, and actually sell it and make revenue on the store. So definitely check out the asset store. There's tons of great things there. And one thing I want to last talk about before we get to Q&A is Bolt visual scripting. And I don't even have a slide for this because we literally just announced this about 2 or 3 hours ago. Let me bring it up. If you're not a programmer, but you want to get into Unity, or you want to use, maybe you're a modeler, let's say, and you're like, I've always wanted to make games. I'm good at making art, but I don't know how to code. Let me just bring it up here on a side monitor. We have this visual scripting tool that we just made free today. So I'll bring it over. So Bolt visual scripting takes a lot of the code work that we just wrote out of the equation. It becomes these graph-like nodes. Excuse me, where you don't actually write code. You just connect logic where it's like, take this this tank in our game. I want it to move forward. We can put in if conditions, like with these little windows, and then have a follow the arrow to, the tank move forwards or it moves backwards. You don't have to write any code. You just have to connect a bunch of nodes like this. This has been super powerful. You can create entire games without writing a single line of code. And like I said, this just went free today, like literally 3 or 4 hours ago, we announced it. So if you're not a coder and you want to get into Unity and the coding has been a challenge for you, definitely check this out, completely free of charge, and you'll be able to get a little bit farther. At this point, I think I like to turn it over to the QA, and we'll see here. I think on our, I'll stop screen sharing just for a second. If we have any questions directly in the Zoom meeting chat, I can answer them here. I will also open up Discord. From what I've heard, we have a pretty lively community there. Rohan, if you're here, was there a specific channel they should use for this?
Yeah, so if any attendees have any questions, they can feel free to ask those in the YouTube, the Zoom, or in the Discord Ask Mentors channel. We do have one question, which was, how do you add a 2D overlay, such as a game menu, on top of a 3D world? So
Sure.
if you could answer that question, then we'll take some more as they come in. And then I think until 2:30, you can kind of just hang out in the Discord channel and answer some questions from there.
Absolutely. So let's answer that. I will actually show my screen again. So hopefully you should see the tank screen again. So yeah, the question was, how do we have a 2D overlay in a 3D world? Great question. We actually have that built in as well. You can come up to the top and you can go to Game Objects, UI. So user interface is what UI stands for. Let's say we want to have some text on a screen. Maybe you want to count the points in your game or whatever it might be. There's options for buttons, sliders, scroll bars, sorry, drop downs, pretty much anything you'd expect regular like user interface to be. We have options. If you select, like, say text, some text pops up on the screen. This actually lives on a canvas game object, and canvases are kind of tricky beast in their own right. But you can imagine it, and you can kind of see it actually here. It's like this giant, it's really big and hard to see. It's like this giant flat pane of glass, essentially. Think about if you're making like a movie on your phone or with a camera, and you're filming your 3D world, but you just stuck, some text right in front on a piece of glass, and wherever you move your camera, it goes with you. That's what a canvas is for us. So we could go in here and let's go to our game view. You can see it says new text. I can move it around however I want. I can change the values to say whatever it is. I can change the font size. You can actually download and change fonts and everything right here. So I would suggest if you're trying to do something like that, start by going to Game Object, UI, choose whatever option it is, and then hopefully it'll pop up. I'll leave it at that today. Canvases are a pretty in-depth subject. You can do a lot of cool things with them, but yeah, your canvas, it should get you started there. I think I saw another question. I see one here in the chat. Is C# the best language to use with Unity? Also, is the difference between Visual Studio and Visual Studio Code? Yes. So yes, C# is the language you should use. We've had different support in the past. We used to have support for JavaScript when we first started, also Lua. C# is what we've decided to go with. If I know they teach a lot of in high school, regular Java, that's pretty popular. If you use Java before, C# is super close to it. And even then, with the layout we have where you just have like an update, you don't have to fully understand and be an expert programmer to make things happen in Unity. I think that's a very common misconception. To make games or to make apps, you have to be an amazing programmer. And realistically, you don't anymore. And tools like Visual or Bolt, make it so sometimes you can make good games without writing a single line of code, which is amazing. The second part of that question was, is there a difference between Visual Studio Purple and Visual Studio Code? Yes. So Visual Studio is created by Microsoft company. I don't work for them, so I can't say everything. But Visual Studio, just regular Visual Studio, is their full IDE, so their full code editor. And it has, for us, the biggest thing we get from that is IntelliSense. So I will share my screen once again. I should probably just leave this up. So when we use Visual Studio, the regular one, we get some awesome IntelliSense built in. And I think there is some with Visual Studio Code, but we always do the full out version. Normally Visual Studio Code is a lightweight version of this Visual Studio. It's usually intended more for web development. So you see a lot of JavaScript, a lot of like Node.js, a lot of that stuff lives in code, but usually for bigger, beefier projects, we tend to go with regular Visual Studio. So what I was talking about is we can let a lot of the code just write itself for us. I can say, hey, I want to use this transform.translate. I can just start typing in a few letters and it makes recommendations for me. And I can just hit like my tab key and it'll fill it out. And I can say dot, I can see all the functions and different options we have here. I think if you want to become a good programmer, understanding this IntelliSense system is so useful. It'll make sure you spell things correctly to start. It'll give you a suggestion of what you might want, and it'll definitely speed up your code. So I know Visual Studio Code has that for the JavaScript side. I don't know how much Unity support it has in particular. We recommend full Visual Studio. The community edition is free for Unity, but people use even just like TextPad editor sometimes. You don't have to use Visual Studio. You can use any text editor you want, but this is what we recommend officially to use Unity. I think I saw some other questions.
There was a question from YouTube, which was, is there a way we can create backgrounds and characters for ourselves in Unity?
Yes, great question. Usually most people, especially in traditional gaming, create those assets outside of Unity and bring them in. So I always suggest Blender is a great 3D modeling tool. Again, it's free. We don't directly control it or use it. There's also, I think they just changed the name. Let me look it up. It used to be called, is it Fuse now? So I'm trying to find it here. There's a lot of online options that will help you create. So I can't find it right now. I'll try to find it in a second. To find these tools and bring them into Unity. But generally speaking, you don't actually create the assets within Unity. You create them in a secondary or a third program and then import them into it to make them move around and interact. Hopefully that answers that question.
Yeah. And then from the Zoom, what is a good spec for a PC to use as a Unity developer?
Great question. You can actually make fairly basic games on min spec machines. And actually, I think we have an official page I can try to bring up with the official recommended specs. One of the biggest things we see, and it's becoming more and more popular, is can I run this on a Chromebook? Especially a lot of kids I know are in high school. Chromebooks are becoming more and more popular. Unfortunately, you cannot run it just on a Chromebook. You do need the full ability to be able to download the software and have it run. Chromebooks just don't have that capability. You can check out here. I just Googled Unity min specs. This is what they're asking for. It's nothing too crazy. Like a graphics card with DirectX 10 is, I don't know, 5+ years old at this point. Performance will vary. It's like any video game. The bigger, more powerful computer you have, it's probably going to run faster. But you can run base Unity on a pretty min spec machine, but maybe don't expect to be making the next big AAA game if you have a relatively weak laptop.
All right, well, I think that's about our time. Thank you, Ben, for the workshop. It was really informative and really entertaining. I'm going to turn it over to Gary for some updates and looking forward to future workshops. But thank you, Ben.
Thanks for having me.
Thank you so much, Ben. We really enjoyed your time with us. Coming up, if you're on stream with us, make sure to check out our social media, which is synHacks on Instagram, Facebook, and LinkedIn, and synHacks team on Twitter. That's where we'll be posting about upcoming events. And then our next upcoming event will actually be, let's see, it'll be an AMA with Avi Schiffman. He was the creator of endcovid2019.live, the coronavirus tracking website. That's a great AMA to check out. That'll be taking place at 4 p.m. Pacific Daylight Time. And thank you for joining us and have a great day.
Bye, everyone.